Okay, a warm welcome to my lecture and my dear viewers. This video is about a PBT presentation for subject network design. My name is Sharvin Analaki Kaleselvan. My matric number is 25DDT19F1137. Okay, let's start our PBT presentation. Okay, we got three parts in PBT presentation. First part is interpret the result of EIGRP routing. Part 2 will be discuss and share opinion about summarization in EIGRP. Third part will be discuss and share opinion about wasted IP address in the design. Okay, let's begin from our part 1. Okay, interpret the result of EIGRP routing based on output student grade from assign, assessment problem based task output from R1. Okay, let's see. This is our R1. Okay. Let's see what output we get in EIGRP. First, I will show IP route command. Okay, you can see C will be replaced for connected, D will be replaced for EIGRP. Okay, first D will be the network connect, which is summary of EIGRP. The second will be the EIGRP connect, which is to the LAN network of R2 LAN. R2 LAN network is connected to IP route of R1. Okay, and after that you can see the 192.168.9.0 network is a summary, and R3 LAN already shown in the IP route. After that you can see 192.168.10.0 network, which is this network is a summary, and 192.168.10.128, which is R4 LAN network connected to the IP route of R1. And see, this is the network. Okay, let's see our show IP EIGRP command. First I will show the interface. Sorry, first I show the IP protocol, what protocol the R1 use. Okay, you can see R1 used IP EIGRP 10, which is 10 is for autonomous number, system number, and here got automatic network summarization in effect. You can see here we have got three network as summarized in R1, which is network 19.168.8.0, which is one connection between R1 to R2. The second one 192.168.9.0, which will be going for R1 to R3 one connection, and 192.168.10.0 will be using the R1 to R4 one connection. You can see you got maximum path of 4, the routing network using in R1, and you can see routing information sources, which is the IP of serial interface 0/0/0 in this is for R2, this gateway is for R3, and this gateway is for R4. Okay, now let's see show IP EIGRP neighbor. As you can see above the IP protocol, they show the gateway only, but not coming from which interface. Now you can in IP show IP EIGRP neighbor, you can see the address and the gateway, and the gateway come from which interface of the R1. You can see the 192.168.8.0 is coming from serial interface 0/0 of R1, and 192.168.9.2 is coming from serial interface 0/0/1. and DOS gateway is 192.168.10.2 is coming from serial interface 0/1/0 of R1. Okay, now let's go and see output for R2. Go to CLI, enable show IP route command. Okay, you can see 2 is connected directly and another 2 is for EIGRP. The another 2 network is representing of one network is going from 192.168.9.0 is representing the network between R1 to R3 LAN 1. Another network 192.168.10.0 will be representing R1 to R4 1 connection. Okay, you can see it using what IP address for get information of EIGRP and use what interface in R2. Now let's go to show IP protocols. You can see I use routing protocol of EIGRP 10, same as R1. I have no automatic address summarization. I have maximum path of 4. The routing is available for network of 192.168.8.0 network, and we can see what the routing information are getting from. You can see this is IP of the interface serial 0/0/0 in R1. The routing information where the routing information are come from. You can also see clearly where the information come from by giving show IP ERP neighbor command. You can see the IP address and the interfaces are which are come from. Okay, that's all. In output from R2, let's go to output for R3. Same, go to CLI, give command enable show IP route. Okay, you can see two network are connected using EIGRP and two network are directly connected using normal connected method. Okay, first network will be the uh, 192.168.8.0 network is uh, R1 to R21, which is this network. Another EIGRP network is 192.168.10.0 will be R1 to R4 1 connection, which is this connection. It uses 192.168.9.0 IP, which is uh, IP address of interface serial 0/0/1 of R1, which is connection of here, and using the serial interface 0/0/0 of R3. Okay, now let's see show IP protocol. What is the protocol R3 using? You can see IP EIGRP 10, which is protocol R3 using, and you can see the automatic address summarization is we didn't got any of that summarization in R3, and the routing network is 192.168.9.0 network is R3 using, and we can see the routing information sources where the routing information we are get it from, which is the 192.168.9.1 IP, which is the IP address of the serial interface 0/0/1 of R1. You can also see the information the routing information by giving show IP EIGRP neighbor command. You can see the address where the routing information come from and the interfaces R3 using. Okay, that's all in output from R3. Let's go to output from R4. Give enable command show IP route. Can see three network is connected via EIGRP and two network is connected via EIGRP and two connected network connected is directly. Let's see the EIGRP routing because we are interpret the result of EIGRP. Okay, the first network will be 192.168.8.0 network, which is the network of R1 to R2 one network, and second network will be 192.168.9.0, which is one network of R1 to R2 R3. Okay, let's see the routing information by giving show IP protocols. Okay, we can see the routing protocol is using EIGRP10 autonomous number 10, same as R3, R2 and R1. And we didn't have any automatic address summarization. We got the routing network of what the R1 network is routing and the routing information sources. Where's the from where the routing information is come from, which is the IP of 192.168.10.1, which is the IP of interface serial 0/1/0 of R1. We can see clearly by giving EIGRP show IP EIGRP neighbor. Okay, can see the address and the interfaces which the address of routing information came from, and the interfaces are for use to get the routing information. Okay, we are done our part 1, which is interpret the result of EIGRP routing. Okay, let's go to part 2, which is discuss and share opinion about summarization in EIGRP. Okay, should or should not summarization enable in this design? Why? Okay, my opinion is summarization should be enabled because route summarization is a way of representing multiple network with a single summary of address. It often used in large network with a lot of subnets since it decreasing the number of routes that routes have to maintain and reduce routing updates. Why the summarization should be enabled in this design? Because if we did not use summarization, we will need more bandwidth and have to use larger packet sizes. We can reduce the size of packet and utilize less bandwidth if we use the summarization method. As a result, routes are advertised with a single line. Use the route summary approach. Okay, this is my first opinion about should or should not summarization enable in this design and why. Okay, the second is about would route summarization occur in a non-hierarchical design? Why? My opinion is no. The route summarization not occur in a non-hierarchical design because this is my opinion, because route summarization is a commonly used with a large number of network. It is similar to a hierarchical architecture because a non-hierarchical design network is isn't very large. As a result, packet size will be tiny and bandwidth will be used wisely. Okay, that's all in my opinion about would root summarization occur in a non-hierarchical design. Why? Okay, I'm done in part 2. Okay, now let's begin our part 3, which is discuss and share opinion about the wasted IP address in the design. How many IP address in the design are wasted? Support answer with a calculation. Okay, let's bring our calculator first. Okay, um, you can see two subnets is using 255 IP addresses. We got if 2 means each 2 using 255 subnet means we got 4 balance 4 divide sorry 6 divided by 2 equal to 3. So each of that using 255 IP address, so we times by 255 of that. So total the 6 of the subnet is using 765 IP addresses. Okay, total okay, in top you can see here they given the IP address include 192.168.8.0/22. Okay, 22 subnets means it have 200 uh 200 slash 22 subnet means it got 1024 hosts. So 1024 we have to minus by 2 because of the one will use to define the subnet, another one is used to define the broadcast IP. That's why we uh, minus every time we get the host we have to minus 2 because of that. One is for subnet, another one is for broadcast IP. So balance we got 1022. So we minus by the IP get it from the subnet. So the IP we get it from the subnet is 765. So minus first we have to give the host IP and minus by the IP we are used in the subnet. So we got balance 257 IP. So these are the wasted IP in our design. We waste 257 IP in our design. Okay, this is my calculation. Okay, second will be what change should be made to this IP address scheme to be more efficient. Suggest the new subnet assignment and fill in the table below. Okay, I suggest the new way. We have to add two new subnet. The two new subnet acquired same as usual 200 25 per two subnets we have that we have created. So plus we previously spent 765 subnets for sorry 255 for new subnet that we created plus 765 IP address that we previously created. It's became a total number of 1020 of IP addresses. So if we minus from the host, we get it from the uh, 20/22 subnet. We have minus of we have balance of two IP address. That means we use the IP address more efficient because we have leftover of two IP address only. This is my new subnet assignment. Okay, that's all in our PPT presentation of subject network design. That's all from mine. Thank you very much.